let's welcome our speaker, Paul.
Thank you. Thanks, everybody. My name's Paul Grizzaffi, as Dr. Wong said, and I'd like to thank you and Dr. Wong for having me here today. We are going to talk about automation in practice, a little bit about what you might see out there, and a little bit about what I really think it should be instead. So just quickly on my background, I'm the automation program architect and manager for Med Assets. We're a hospital performance improvement company where what we do is we look to help hospitals either decrease their spending or increase their revenue by applying software tools and some bulk purchasing and stuff like that. I've spent my career focused on automation, and I like to consider myself and my team software pediatricians. Most of you probably have heard the joke that software developers are the ones that have the baby and the testers are the ones that come in and say your baby's ugly. So what I like to think of is my organization and the testers and the QA guys come in and say, no, what we're going to do is we're going to help this software, your baby, grow up to be healthy and something mature that we can deliver to our clients and our users and our customers that they're going to be happy with. I'm also advisor to an organization called the Software Test Professionals, and they're the URLs for both their site and the conference that they put on called STPCon. They have that conference twice a year, and they don't really have a track, but if they did have a track, I would be the track chair for automation there. And the organization, basic membership's free. You can go and sign up and you can get some articles and information that are sort of general testing interest. Then there are higher levels of membership that get you webinars and different things like that. Here's my contact info. If for some reason you want to contact me outside of this forum, feel free to. And then other than that, we will go ahead and jump in. So when I say automation, what comes to mind to most people? When I talk to people out in the world, I hear a lot of the same types of things. I hear about scripts. We're going to write test scripts. And those test scripts are going to come from test cases. And what are we going to do with those test cases? We're going to take them, we're going to put them in a tool, and we're going to have these scripts, and we're going to run them in regression. Because regression is where we spend all of our time. Regression testing is where we spend all of our time, in quotes, because that's true or it's not, depending on which organization you're actually in, which company you're actually in. And what's that going to do? It's going to save us time. I'm going to have all this time to do something else. Well, wait a minute. If I have all this time, then maybe they don't need me anymore, so they're going to lay me off. Hey, but don't worry. This is a lot of work. It's going to be years and years and years before we get all this stuff up and automated. So don't worry about your job just yet. And it's brittle. Hey, I worked at this other company where every time we put out a new product release, we had to re-record half of our scripts. It takes a lot of time. You know, it's not something we can sustain release over release, so they're not ready to get rid of us yet. And it's inconsistent. You know, test case 247, it passes most of the time, but every now and then it fails. We just rerun that one, and if it passes, all good. And then test case 7,422, we never really got that one working, so when it comes back as a fail, we just ignore that one and we say it's okay. Who here's worked out in the industry in testing or software or something like that? Anybody? Okay, one, okay, two, okay, great. So does this sound familiar? Have you heard these types of things? Have you said these types of things? I've said some of these things, right? I mean, in my career, I've said many of these things. So what's it like out there? I mean, is it really the zombie apocalypse of automation and testing and it's just hell on earth? It depends who you talk to. You're going to hear a lot of things regarding automation and testing. One of the big ones is the executives are going to come in and say, how many scripts do you have? How many scripts do you have? How much is automated? How much of your regression is automated? Hey, why aren't you using QTP? Or UFT, or Selenium, or Renorex, or whatever it is that I read about in CIO magazine. Why aren't you using that tool? Why are you using this tool instead? Why do we need testers? Hey, Microsoft doesn't have testers anymore. They have SDETs, software development engineers and testing. Why do we need testers anymore? Let's fire all those guys, man. Let's just get the developers to do the testing. So what you're going to find out in the real world is, in general, when you talk to people about automation, it is based on test cases. I have this backlog of manual test cases, and I have human beings clicking these buttons and driving this mouse or sending this message through, and I want a computer to do that because I have this much to do and I'm getting to this much of it. I want the computers to help me get over, right? There's a big focus on smoke and regression. By smoke tests, smoke or sanity, I don't know which vocabulary y'all are using here, but those are usually quick, high-level tests to see if your product is egregiously broken. Usually you will run those right after a new build or right after a push to a different environment to make sure the push kind of went well and that you didn't break anything that's your top percentage of what your features are. Big focus on UI testing. If you look out there at the test tools right now, many of them focus on UI, specifically web, because our products are not built to be testable below that in many cases. Fortunately, we're seeing some changes there. Many of the third-party companies, the companies that provide test tools, will provide interfaces for web services, so SOAP and REST and different things like that, that you can bake in with your UI testing. So we're slowly seeing that pyramid shift to be a little more in the right direction, but we're not there yet because a lot of the products are old. A lot of the products have been around for, well, since the beginning of the web, right, when all the retailers jumped online. It is very tool-centric. When I go to conferences, when I go to meetups, when I meet people and they say, oh, you're in testing, you're in automation, what tool do you use? Almost always the first question out of their mouth. Almost always. And tools aren't bad. I love tools. These are great. And mostly what you're going to hear about is Selenium or QTP. QTP is provided by HP. It was bought from Mercury, and there's a long backstory on that. But very tool-centric. Very, what tool are you using? What tool are you going to use to drive your automation? You're going to hear testing is dead. No, testing is not dead. No, this kind of testing is dead. No, testing is this. Testing is that. If you go out and listen to the thought leaders, or as I heard the term yesterday, thought lords, or as I heard the term back at a conference, which I really like, the industry vocalists, those that have something to say and have a platform to say, they're going to say testing's dead, we should be all just developer engineers and we all develop the product to go out. Or no, testing's a specialty, it's a craft. And that craft is something we need to develop and nurture. Go out, read the literature, form your own opinion on what you like with that. And SDETs, I mentioned that before, software development engineers and test. I think Microsoft sort of came up with this term and this notion. A lot of companies are looking at this now. I know that there's a company in town that's hiring, and they used to have positions for automation engineers or automation developers. Those all went away, and now they're all SDETs. I don't know why. I don't know what distinction they're making there, or if that's just the term of the day. Again, nothing wrong with these guys. I actually have one of these guys on my team. But is that in place of a tester? Again, what's appropriate? What works for the team you're on? What works for the product you're in? So, Princess Bride fans? Anybody seen Princess Bride? Okay, 2, 3 people. All right. So as our friend Inigo Montoya says, or I paraphrase from him, I do not think it means what you think it means, that word. Automation means something different to me. But before we go start talking about what I think it means, let's talk about traditions. Traditions, much like Thanksgiving in America, is important. Things that we've done before are important. And traditional automation, I bagged on it a little bit up front, it's important. It can detect behavior changes. It can reduce your effort on smoke and regression. It can execute earlier. Hey, on every check-in, I want to run my smoke test to make sure that the last change in the code did not egregiously break what our product does. And scheduled execution. Yeah, my regression automated takes 8 hours to run. Well, I can't run that on every push. I can't run that during the day. I'm going to do that at midnight. When I come in, I'm going to look at the results in the morning. Very valuable. Most companies do this, and this is what they call automation. We do it. We do this. It's valuable. It has found problems before it made it out to the field, before it made it out to our users. Nothing wrong with this. But is there something more? Is there something else? I look around and I start looking at what the testers are doing, and I think, couldn't we put some machines to help you do that thing? That thing really looks like it's it's not fun, or it's really time intensive, and I could be having you go do something that's more human valuable. So what if we think differently? This is a picture of the Fortis exoskeleton, or a guy wearing the Fortis exoskeleton. And this is developed by Lockheed Martin, and I believe the Navy is or was interested in this particular thing. And it is something that a human being puts on, and it helps them hold heavy, awkward, difficult to handle things for extended periods of time. So what this guy is holding is a grinder. I don't know anything about the grinding business, but I'm going to assume, based on what the skeleton is for, it is awkward to hold and use and drive. They could have said, hey, I'm going to build a grinding robot. So I'm going to build a robot that's going to do all my grinding for me. But they didn't. For some reason, they said, we're not going to do that. Either because it wasn't cost effective, it was too non-deterministic. They could not get the value out of it that they were trying to get out of it by inventing this robot to do the grinding. So they said, let's just help the humans do their job. So that's what I start thinking about when we think about automation. Let's help the humans, right? The valuable commodity in this whole operation is the human being, because we're the ones that have the limitations. We're the ones that have needs. We need to sleep, we need to eat, we need to go home to our families, we get sick. Computers don't do all that. But computers can't think the way we do. They can't notice things the way we do. You have to tell them what to look for, and if you don't tell them to look for a certain thing, then they're not going to. So let's help the humans do their job. And let's think about what makes the humans, in this case the testers, be more effective or more efficient at their job. Think about what's valuable. Again, what's the valuable commodity here? The human's time, our time. There are things that we can do that the machines cannot. Therefore, let's focus the machines on the things that we cannot do or should not do, and have them focus on the things that they can do very, very well. And then talk about what hurts. Everybody has a job, and in that job, there is at least one thing that is just the bane of your existence. Right? There's something about that job that is just terrible, no matter what job it is. Greatest job in the world, there's some paperwork, there's some data creation, there's something in there that's unfortunate, that's taking your valuable time that you wish somebody else would take away from you. So we can talk about those things as well. So instead of automation, what I like to think about is assistance. And this is where we coined this term, automation assist. I wish I had created it, but it was really my boss and another guy at a previous company invented the term for some things that we had been doing anyway. And automation assist is an umbrella term for non-traditional automation. If you think about automation as test case based, we're going to take test cases and turn them into scripts and run those. That's what I would call traditional automation. We're going to talk about some non-traditional stuff today. And this quote, I believe this is a reword of a more famous quote by someone that I don't know, but Patrick Amaku is a guy that I worked both with and for at Nortel for many, many, many years. A guy I like and respect a lot. And his particular wording on this really rings true with me. It's stuck with me all these years, that words mean things. So the word automation is a very loaded term. It means things to most people in our industry. So changing that meaning is going to be very difficult. What we decided to do was coin a different term to talk about a different thing. So specifically when we talk about automation assist, we're talking about, in my world, sort of three classifications of things. One is called off-label tool use. If you're familiar with the pharmaceutical industry, off-label use of a medication or a drug is to take a drug or a medication for something that it was not originally intended for, but does work for. For example, my mother-in-law has macular degeneration in one of her eyes, but she does not take a macular degeneration medication. She takes a cholesterol medication. Why? Because it retards that macular degeneration. It helps slow it down to the point where it's not really progressing at an appreciable rate anymore. Plus her cholesterol is good at that point. But that's sort of an off-label use there. Off-label use in my tools world is taking something that was originally intended for traditional automation and using it in a non-traditional fashion. We'll see an example of that. Sometimes you have to create new stuff. You're in a specialty place. You're doing a specialty thing. something off the shelf either is not going to fit your need from a technological standpoint, or it's going to be too expensive. I call it swatting a fly with a Buick. You don't need a big enterprise class tool when you could just write a couple of Python scripts and get done with that, and then you will move on to the next thing. And the third we're not going to talk about here, partially in the interest of time and partially because that third bullet is really geared toward those people that do not have programming experience. Where we talk about tools not traditionally thought of as automation. I focus a lot on command lines because a lot of these people have not been exposed to command line tools like find string or grep or awk or set or anything like that. Y'all primarily Windows here, you learn multiple operating systems, you understand Unix, Linux, okay, cool. So I grew up in a Unix, Linux world, and I worked in a Unix, Linux world for 16 years. So those are my go-to words. So grep, awk, sed, those types of things. And they have counterparts over on the Windows side as well. And these can be very valuable in building up little helpers to help you do your job. But y'all already know about all this stuff, so we're not going to spend any time on that. So like I said, let's look at some specific examples from multiple companies in my career where we actually use this automation assist approach to provide value. So the first two examples are under the context of this data center move we were doing. It was a data center migration from a data center in Richardson to Louisville. And to call it a migration was sort of generous. It was really more of an evacuation. We were being kicked out of the building for several reasons, and we decided what we were going to do was we were going to take only those things which may not be kicked. All right, so we were not taking the servers, they were old. We're not taking the wires and the cables and the racks and the frames. That was all old stuff. It was going to the recycler. Some of it was several years out of warranty, so we decided that we were going to invest in new. So what we're doing is we're taking this existing software and data that we sort of understand the way it behaves, and we're plopping it into an alien world. New servers, new operating systems, new server configurations, new network topology, new everything for those things that may be kicked. All right? Holy crap, how are we going to test this? And this is for multiple products, and some of the products are quite large and quite complex. So that's the context for these first two examples. The first example is a tool we created called MERV. And in the military industry, MERV stands for Multiple Independently Retargetable Reentry Vehicles, which is a really fancy, politically correct word for a missile that goes up and then sends down individually targeted missiles to individual targets. A little bleak, but we like our military references where we are right now. And we will see the independently targetable part when we actually get into the example. So what were we doing here? The premise of this particular tool, or why we created this tool, again, was a data center migration for one of our arguably largest and most complex products. Big surprise, aggressive dates, limited staff, limited time. But we had two really, really good pieces of data. Piece of data number one, we know how the system behaves today in the environment it's in today. That becomes our oracle, a real-time oracle. So if we're in the new environment and something's not behaving the way we expect, we can go and reproduce it in the original environment and say, did it work that way today? If not, then it's something we need to sort out. If it is, it may still be a problem, but we're not going to fix it in the context of this data center move. We don't have time yet. The other piece of data that we had was the year before we migrated, which is arguably our second largest and second most complex product. And what we found out was regression, deep testing, not valuable, because either the system was basically going to work or it was going to be egregiously broken. I don't like that word egregiously, you'll hear it a few times. We're not going to see, I was off by a penny, I was off by a percent, not a lot of off by one. What you're going to see is I got data back and it's correct, or I got a 400 error, I got a 500 error, I got a server crash, I got no route to host. So things on that level. I got no data at all because I was pointed to the wrong database. So we're talking about checks at a very high level because we know what to look for here. So our context, our frame of reference is relatively small, even on a large and complex product. So what did we do? We created some test scripts, and we used a commodity tool to do it. We used a tool called Test Complete, which is a traditional test case-based test scripting tool, but we used it off-label. We created a different type of approach using it, still scripts, but we didn't do the same type of testing you would normally do. Enter these calculations, make sure we got these answers out, make sure the answers are correct. No. What we did was we wrote the scripts to get to various portions of the system through the web. Just by arriving at a certain page, or just by ensuring a certain HTML element was present at all, we knew that certain things were up and running. Because we could check those things directly, but that only meant they were running. It didn't mean all the plumbing to get it actually to the end user was all there. Because remember, we're in a completely new world. New network topology, new routers, new routing tables, new everything from a hardware standpoint. So we had to verify that all that stuff worked for 1,200 hospital facilities across about 6 weekends, I think. So do the math. We were migrating anywhere between 100 and 600 hospital facilities per night, which means 100 and 600 databases per night. We could not do that in the 4 to 6 hour time window that we had with human beings, and we couldn't even do that from a computational standpoint with the amount of hardware we had. So we had to do things in parallel, and we had to steal, beg, get hardware. I talk about the fact that we used repurposed laptops here for 2 reasons. One is it was very economical. I went to the hardware team and said, hey, I need some horsepower just to run some browser testing. Well, we've got these Core 2 Duos sitting on the shelf here that are about to go to the recycler. Want them? Yes, I will take 30 of those, please. So we had a room, and it was very hot in there, running 30 laptops with just running our test automation there, but all running against different hospital facilities at the same time so that we could deliver data back to the test team as quickly as possible. And again, we used Test Complete, which is a product called, by a company called SmartBear, and it was several weeks of effort. I don't even remember. It was a really rough time. We worked a lot of weekends for this product, or for this project. So why do we take this approach? Scaling, right? Again, 1,200 hospital facilities. We're doing chunks of multiple hundreds on most nights. For a human being to do one of the facilities was 45 minutes. Again, do the math. We don't have time to do it, quote, manually. But we knew that quick, shallow checks were going to maximize the human's time. So what we did was we divided up the facilities for a particular night. All the ones that were critical, our bigger customers, the customers we messed up on last time, the customers we have bigger penalties if we mess up, the ones that were really critical for that night, the humans focused on those. We ran our stuff too, because sometimes our stuff would get there before the humans did. But the humans were focused on those, and we were focused on the other ones, because it's not that they weren't important, it's just that we only had so many humans, so we had to make a choice on what we're going to spend their time doing. And then if we found something that was a little out of the ordinary, we would let one of the testers know and say, hey, we found this problem, is this something to worry about? And let them figure it out, because my team's the automation team. So we know a little about testing, we know a lot about automation, and we're effectively software developers who are providing products to our internal testers. So when it comes to the product domain knowledge across 20 products, a team of 5 can't know that. So we have to rely on them for the domain knowledge. They rely on us for the automation acumen. The existing tool, we use what we had in-house. We had some framework stuff built up. We had to build a little more. We had to add some scripts. But because we had the licenses, we had the plumbing, we had the training, the effort to roll that stuff out the first time was relatively low. So that's why we made that choice. And they do weird math on these business critical incidents, but somewhere conservatively between 7 and 12, really generously, business critical incidents were prevented. And in our world, a business critical incident is an outage where either a product or a part of a product is unavailable for a customer. And these things are really uncomfortable. They're conference calls, they're executives on the call, sometimes they're actual client interfaces on there, and basically this happens until this problem is resolved. So that's 7 to 12 times that we didn't have that. 7 to 12 times we potentially did not have to pay a penalty. 7 to 12 times we did not potentially lose a customer. So very, very impacting here. And you'll hear a lot about value in this conversation because a lot of times we focus on technology, the tech. What's the tech? Can I do it? Should I do it? The can I do it is the part where we're good at. The should I do it? That's the value part. We're not as good at that. We need to get a little more, as sort of an automation initiative industry-wide, we need to get a little more value-centric in deciding what and how to automate. So also under this data center migration, we use a technique or set of techniques called high-volume automated testing. Now, high-volume automated testing is not performance test, capacity test, load test, any of that stuff. This is a different approach to testing, and this is from the workshop on teaching software testing. The family of testing techniques that enable a tester to create, run, and evaluate the results of arbitrarily many tests. You'll hear this called HiVAT, and recently there's been a little more chatter about this, but there's not a whole lot of info out there. There's not a whole lot of stuff going on outside of Florida Institute of Technology. Dr. Kim Kainer is the sort of the originator of this, along with some other people. And a guy named Andy Tinkham has been doing some presentations on it. So if you look up Kim Kainer, Andy Tinkham, and HiVAT, you can get some of this information. The main jumping off part for the rest of the information is at this URL. But for us, the interesting facets were many executions, random executions, and the fact that the results are being vetted by humans. A little different than what we normally talk about. So this project and this tool was called SCUD. And the premise here is that same product we were talking about last time. It's large, it's complex, it's aging. And the fact that it's aging means that automatability was not thought about when they originally made it. So some of this stuff's difficult to automate. There's some nooks and crannies that are very hard to get into. The solution for this particular concern around the product was something we called SCUD. If you're not familiar with SCUD, again, it's a military reference. SCUD is a missile, and it is notorious for its faulty guidance system, or at least it used to be, I don't know if it still is, where you would launch the missile and it might not always go where you expected it to go. So what we did was we came up with this thing called a random menu clicker. We were going to just click on every link, but there's some context sensitivity around some of that. We were getting so many false positives that it wasn't worth going with that approach. But the idea is we would randomly click on different menu items and look for things that weren't right. How does a computer know what's not right? Well, we had to tell it what to look for. So obviously 400s, 500s, Internet Explorer cannot display this page, our own 404 page. The word error appears on the page. And if we find any of these things, we take a snapshot, we flag it in the log file, and we leave a trail of breadcrumbs of how to get back to this thing. How do we produce this in the first place? And at the end of the run, this is delivered to the testers and said, we found 4 things that didn't seem right. Go have a look at those. And we were doing a push at that time, so that one's not valid. That is valid, but we knew about that one already. Hey, that number 3 is a new one. How did you reproduce that? How do we reproduce that? Well, you can go to the log file and see all the steps we took. We changed our tech stack for this one. Selenium, we went with Selenium and Python, and it took about 4 days, about 32 hours of effort. Again, that was larger than what I expected because we were going about this from a link standpoint instead of a menu standpoint. And we wanted, this was a smarter way to go. But we found 4 issues just in the first week of use. Just in the first week of use, 4. Any one of those 4, or all of those 4, could have wound up being business critical incidents where we have those uncomfortable conversations on the phone and potentially have some sort of financial penalty. So why do we go with this solution? I used to work at GameStop in their e-commerce and digital delivery unit. And we wrote something similar that just clicked on the links, and there was value there. It was very cheap to create relatively for the number of problems it was finding. And again, it was based off of HiVAT, so we're not experts in HiVAT at all, but we certainly were aware of it, and the principles and concepts made a lot of sense to us. Test Complete was not appropriate. That's why we switched our tech stack. Test Complete, much like many of the vendor purchased tools, they like to be the boss. So they've got an IDE, much like your development environments do. It's got an IDE, you work in the IDE, you run the stuff. And as long as you're not getting too far out of what they're expecting you to do with their tool, it works pretty well. And this is not a ding on Test Complete. All of the, or almost all of the commodity tools have this same limitation and thought process. I like Test Complete. There are things it does well and things it doesn't, and this is one of the things it doesn't. So we switched. Also, Selenium is open sourced, so I had broad license usage. I did not have to worry about, can I connect to my license server? I can run it anywhere. I run it in the cloud, I run it at home, and I did not have to compete with the purchase licenses for Test Complete. I did not have to make a decision, do we run MERV? Do we run SCUD? Well, I can't run MERV as fast because I got to run SCUD at the same time. No, we didn't have to compete for those licenses. We could run them all in tandem, as many as we had, and then our hardware became our problem, which is a different problem. Why a scripting language? Why do we go with Python? We went with Python because, in my opinion, learning a scripting language is typically, well, Perl aside, learning a scripting language is easier than learning a traditional, strongly typed, compiled language because you don't have a lot of the syntax decoration and you don't have the strongly typed nature. You get a lot of the duck typing. Familiar with duck typing? No? Okay, familiar with the walks like a duck, talks like a duck, probably a duck? Duck typing is sort of the same thing where if you pass an object to a function, to a method, and you call length on it, as long as that object respects length, it doesn't matter what type it is. It only matters that it respects the interface that you're calling into it. So there's some lower syntax requirements, some lower type requirements. Development is faster because you don't have to worry about a lot of this stuff. Now, faster is purposely in quotes because obviously scripting languages have a limitation, and that is you don't find out about a lot of compiler-caught problems until runtime. So if you're building something that needs to be a little more durable than what we were doing here, you're probably going to have to add some additional unit tests to check for these things simply because you don't want to be running and after an hour of runs you get some sort of null pointer exception and your whole run just goes to heck and then you're done with it. And Python is not my favorite language. I prefer Ruby. But in this area, it is easier to find Python experience, therefore it is cheaper to find Python experience. So if I needed to bring in help from outside, I could do it in a more cost-effective manner if this was based in Python. And the reason we went, again, with Python as a scripting language was at the time, I thought we were going to shift our corporate paradigm away from C#, not in the products, but just in my tools area, from C# over to Python. We made different business decisions since then, but that's why that was here. Next example is a data regressor. This is a couple of steps back in my career where I worked for a company called TradeStation. And TradeStation is, you can think of it a lot like Scottrade or E-Trade, but on steroids and geared toward day traders and option traders. So this particular thing, I worked on a team called the data team, and there were various different servers in the data network that helped provide information to the other components of the system regarding stocks. We need to perform regression testing between software versions, and I've got regression in quotes there because it's not regression the way many of us think about it. I have a test, and I run the test, and then if it didn't break, then we're good. I know what the answer is supposed to be, or I can compute the answer, or whatever it is. We couldn't compute the answer here because the testing was bring up the old version, bring up the new version, type a symbol in both, and make sure that the data came back is the same. Because some of it's delivered directly and some of it was computed. And I think they were doing this for like 100 symbols. So imagine, you're sitting at your desk, oh, we got a new version of the server. You got to bring up the old version, bring up the new version, bring up the interface, type. Did it match, did it match, did it match, did it match? 8 hours of this, 8 hours of effort of this. So it usually took probably a day and a half, 2 days of actual human time to do this work. Why couldn't we replay this stuff? Well, we did. We had a replay capability, so we could do a lot of the testing from hey, we know what the answer is supposed to be because we're replaying it. But some of the exchanges deliver this information encoded, and they don't give us the decoder for it. So we depend on them. We're either working on their test feeds, and we can say, hey, can you send a message that's configured like this? Oh, yeah, we'll get to that in an hour. We'll let you know when it's coming. That's not an effective test strategy. Or in some cases, we just had to work off their live feed. So we had to do it live to make sure we were getting the right thing. We also worked with lower volatility symbols, so the chances of the difference between when you did it in the old version and the new version, the time there was going to be small enough, and the fluctuations going to be small enough that you don't get a lot of, oh wait, it's different, is that a bug or is that a stock market fluctuation? To me, this is screaming, let the computers do this. This is not a valuable time for humans. It's a valuable thing to do, but it's not a valuable thing for humans to spend their time on. Testers are much more talented, much more valuable than being able to do this kind of thing. So I wrote this comparison tool in C++ and just ran it, and it took it, a minute to execute. Of course, there was some upfront effort, don't get me wrong, but a minute to do what it was taking testers a day of effort to do. Yeah, so it was a break-even point was about 6 weeks. I don't remember what the real amount of effort we poured into doing this, but it took about 6 weeks because we would get a server once a week or maybe 2 servers in 3 weeks or something like that we would have to test. Why do we go with this solution? Again, traditional test scripts are not appropriate here. Traditional test scripts, your Oracle is something you're going to compute. You know what the calculator is, so you figure it out. Or something you know already. It's a golden file, a golden value, something that's in a data file or hard-coded in the script that you do your comparison against. We couldn't know that here because we're dealing with hot data coming in. We had an existing API into this portion of the product, so it wasn't moving the earth to invent this API and get all the data tunneled through. We just had to do some additions there. C++ was the primary development language for the developers at the time. So by going with C++, I could say, hey, I need some help doing this. I can't get it done in time. Or, hey, we're done with the first cut. I want to hand this off to somebody else to take it over. If I picked a different language, then they would have, they would not have been able, as willing or as quickly able to pick up and run with it. And we found a product bug during just the first real execution of this thing. Now, I talk about finding bugs here not as a backpat for myself or my teams, but to show that these things provide value. We can find problems in products with non-traditional approaches. And I give this presentation sometimes to managers, and I've given it at a couple of different conferences and such. So I like to really drive home on, guys, this works. This is an approach that works. And the reason it works is because it's still exercising the product in some sort of a way. It's finding stuff. It's just not the same way you would normally quantify it. You can't say how many test cases do you have here. I have 1, or I have 100, or I have 1,000. It depends on how you divide up and what you call a test case or a check or a test or whatever vocabulary you're going to use. Okay, so jumping back to MetaAssets now, we created a results dashboard. Wait, why is this automation? It's automation because we're applying technology to help our testers be more effective or more efficient. So the premise here is that tool we talked about earlier, which is, obviously I spent a lot of my team's time on this, exercises the back end and it's of the product, and it does batch processing. And what it does is it generates these thousands of files and compares them to the golden files, the data we expect, and generates these thousands of results. The problem here is you get all these results and they're scattered all over and you can't tell the failures and there's no trending. So they came to me and said, hey, what can you do about this? I said, well, the right thing to do is put all of this into a test management system where your results get in. So yeah, we're working on that. We're working on that. That's still going to be a couple of months from now. All right, so let's do this then. Let's give you day -1. I'll tell you what today's run was and delta it with the previous day and give you a trend. Yeah, we'll take anything you can give us. We want all these histograms and all these, we'll get to that later. So what we did was we wrote a program. The program would just collate all this and give the day -1 information. We wrote it in C# and it took about 2 days. So why did we go with this? We identified the minimum behavior. Where's the value? Where's the biggest bang for the buck? We gave them that so they could get up and running, and then once they used it a little bit and they said, hey, I need another couple of features here, we added a couple of small things for them. They're using it today, 2.5 years later, still using this. We have a test management system, but they're using this for quick, dirty, immediate information. Why C#? Why not Python or Ruby? Much better language choices for this from a programming standpoint, in my opinion. The reality is, I didn't know who was going to run it. I didn't know where it was going to run. I didn't want to have to deal with Do you have the right version installed? Do you have the right packages installed? No, here I can just build up an executable, hand it off and say, go get it off the share. You want to run it on the web server? Great. Want to run it by hand? Great, I don't care. It's available, so I don't have to care about how it's going to be used. And I know you can't read this, you're not supposed to, but this is the kind of thing that we deliver. The interesting bit here is we've got the trending. And mostly, this is what the higher ups say. And they want to look at that, they want to look at trends. The testers, they care about this stuff, right? So they look at it and go, wait a minute, we trended down, I should be at this percentage. Now I know where to go and look in the product. I know where to go and poke and prod to find out what's going on here. All right, now last example, and I like this example a lot for a reason that a lot of people don't think of. It's called the zero remover. But before we get in, question for you. Is it worth automating something if you're only going to do it once? I get a yes. I get a lot of people that are looking hungry, tired. Okay, right on. Anyway, so the right answer is sometimes. The right answer is sometimes. So the premise here is that same tool with all those thousands of golden files, very valuable. A lot of work went into that. A lot of test scenarios, pump out all this data and do this matching. But a product change causes the database to return a null instead of 0.00 in some cases. Not in all cases. So it's not like we could just say, change all of those zeros to nulls and be done with it. No. The humans, the testers, were going to have to go in, they were going to have to look at each file and say, I found a 0. Now let's see, is this in one of the, nope, that's not one of the cases. And then find the next 0. You know, is that one of the cases? Yep, that's one. Let's pull that one out of there. I about fell out of my chair when they told me what the effort estimate was here. 4 to 6 weeks of human time to go through this stuff. But they were going to have to do it. The results and the testing that this tool was providing for them was so great they were going to invest that time. But by this time, they'd seen that dashboard thing and said, hey, we got this idea of this automation assist thing. Can you help us with this? So I've got them sort of thinking the right way. So they came to me, thankfully, and said, yep, let's dig in there. Let's look and see, is this a deterministic thing that we can parse and do this data transformation for you? And fortunately, it was. And it took about 5 hours to develop this thing. I mean, a little over an afternoon, no problem. Why this solution? We knew it was disposable. It's a one-time thing. It was so special purpose. I didn't even write a parser. I did basically read a line. Does it contain this XML tag? Okay, great. Now we're in this mode. And then does it? Oh, nope. Now we're back in the original mode. I mean, this was really quick, dirty. I'd be ashamed to show you this code. But it's what we needed because we needed it done quickly, and we're going to do it once. And without exaggeration, other than the initial incremental builds, we ran it 3 times. The final time for me to say, ready to go. Once for the test architect to go, looks good to me, and once for the test architect to actually execute it in production on the real data. Then we're done. We've not run that again, still in the repository. I might need to change that code one day, right, resurrect it. But we didn't spend a lot of time on this up front. Again, we're a Windows and .NET shop, and I didn't know who was going to run it. Were they expecting me to run it? Was a test architect going to run it? Was our India team who actually performed this automation, were they going to be the ones running it? Let's build it in something that's easy to distribute, easy to hand off. And don't forget about record and playback. I'll just take a minute on this. Record and playback. You know what that is when it comes to automation? What's record and playback?
Like macros, you record clicks and things like that.
Right, you record clicks, and some of the more advanced tools actually will do it not positionally. They'll do it more of a relative place in the product. Some of them will actually dig in and get HTML web elements for you if you're dealing with a web-based product. But generally, they generate either code that's not maintainable, code that's hard to understand. Sometimes they generate proprietary stuff that you can't really go in and maintain. So record and playback gets a bad rap because it is marketed as you can write your test cases faster this way. You can write your test cases, your test scripts quicker, and then you're up and testing. That's great. And that would be great if the cost of automation over time was test case creation. It's not. It's maintenance. So what you really want to do is find something that is easy to maintain, affordable to maintain, and look at the total cost of ownership of this. So from the more evolved automation people, record and playback is evil. It's bad. I'm here to tell you it is not. It's misunderstood. Record and playback is great for disposable stuff. I know I don't have to maintain it. I need to generate something quick, dirty, get something done, and move on. If you know you're in that position, consider record and playback. It's just marketed wrong. So a couple of words about effort. All of the slides talked about effort or break-even points and value and such. Effort's a funny thing, and effort's a funny thing because it's not necessarily that I'm taking what you used to do and saying now you don't have to do that anymore, some other thing or some other person's going to do it. What I'm saying is I've given you a different tool. So if I give you an axe and say cut down that tree in your front yard, if you're like me, a lot out of shape, I'm probably going to cut down that tree. It's going to take me 6 hours. I'm going to have bloody blisters on my hand, but I'm done after that. I cut down that tree. If you give me a chainsaw, I'm going to do it a lot faster, but I might start looking around for other stuff to do. Those bushes in the back need some trimming. That branch that's hanging over my neighbor's garage, why don't I go ahead and take care of that so it doesn't fall on his garage later? You will find additional uses for these tools, and you will get additional value from that you didn't even know that you were going to get, or that you thought you could get, but you knew it was not cost effective for you to do it. So when we talk about effort and value, it's not a straightforward thing. There's a quote from a lady I respect a lot named Dawn Haynes. There ain't no ROI in testing, and therefore there isn't any in automation either. And she's not saying, because she's a test professional, she's not saying testing's not valuable. She's not saying automation's not valuable. She says there's no return on investment because return on investment is a specific financial term that goes in a specific place on a balance sheet. And that's about as far as I'm capable of teaching you that at this point because I've not done enough research on it. I had this conversation with her about a month ago at a conference. She talks about it a lot in this particular blog here. I suggest you read that. Instead of having the conversation around ROI, let's have the conversation around value. Is it providing value? And a lot of times it's easier to talk about opportunity cost. Opportunity cost is the cost of not doing something because you're doing something else. And if you can get to the second thing, then you waive the opportunity cost of that second thing. And then if you really want to get into a more financial analysis, akin to ROI, but more appropriate to testing and automation, you can look into cost-benefit analysis. And that's some more math that I've not read up on yet. Yes, I'm weird. I've got a degree in computer science, and I'm not so good in math. So, hey, it shows that you can you can make your way in business without being a math genius, which is nice. Okay, some quick takeaways for everyone. This is different. The back half of this presentation is different. So if you're out there and you're applying for an automation developer job, an automation engineer job, and you say, yeah, we're doing automation assist, and I did this and this and this and this, you're probably going to get looked at like you have 12 heads, okay? They want to know which tools have you used? How many scripts have you written? If you got a more advanced person, they might say, hey, what kind of frameworks have you written? Or we have a framework like this for our test cases and our test scripts. Can you help us, go on to the next step there? That should not be discouraging. It's just that not everybody's there yet. And there's nothing wrong with scripting test cases. I'm not here to vilify or demonize that. But it is an implementation of automation. It's not automation. Automation, again, pick your vocabulary, but in general, it's applying technology to make humans more effective or more efficient. And remember, this is software development. In all of these cases, you develop software, which means you're going to have all of the challenges of developing software. You're going to have bugs. You're going to have rework. You're going to have new features. You're going to have, oh, wait, we got a new compiler version or a new JVM version, or I'm going on a new operating system. Plan for that stuff. Situational. This is good. Knowns. Remember in MERV with the data center migration, we knew two very important things. Coverage. Is it direct or indirect? Is it direct like Merv, where we were actually doing things that the humans were going to do? We just allow them to do other things. Or is it indirect like the zero remover? Because we wrote the zero remover and performed that activity for them, they were able to go and provide additional coverage. And what's the usage profile? Who's going to use it? Where is it going to be used? If you don't know, then you want to make it as general and flexible as possible. And think about your lifespan. Not your lifespan, but the lifespan of the thing you're creating. Is it something disposable or is it something long-term? If it's disposable, quick, dirty, consider record and playback, consider crappy code, whatever it is. Long-term, you might want to spend a little more time up front, or just know that you're going to evolve it, so you're going to throw away some things you did up front. Throwing away code's not bad. Throwing away code recklessly is bad. And I'll take questions. All right, great. Well, thank you very much for your time. Thank you.